Hello, welcome back. So in the previous video, we saw OMDM reaction where a 100% markonikoff product is formed. Like there is no major minor, only one product is formed. Now similarly, now we are having another reaction called hydroboration followed by oxidation. Here it is an anti-markonikoff product, 100% anti-markonikoff product. So here what are the reagents in this reaction and how this reaction takes place? Let us see. Now you take alkene, react it with first B2H6 and then H2O2 in any OH source. Then alcohol is formed, okay? And this alcohol gets substituted in the according to anti-Markovnikov addition. Like you can just remember whenever there is a peroxide and stuff, some reverse things happen. I'm just kidding. Like you could remember like that. So whenever H2O2 takes place, anti takes place. It's just a spoiler thing. Now, in HBO, sorry, you take alkene, react it with B2H6. What is B2H6? Diborane. Anyone who have studied inorganic P block, they would clearly remember this structure even in their nightmares. Right? Bridged hydrogen, 3 center, 2 electron, banana or tau bond. Right? So that's the B2H6 we are using in presence of THF, tetrahydrofuran. A THF they may mention or may not mention. Okay, so just look after it. Trialkyl borane is formed. Means some boron compound is formed. Something like this. It looks like this. BRR. Okay, and then you oxidize it. This you oxidize it, and then an alcohol is formed. Okay, let us see the reaction. Just remember the skeletal reaction. An alkene, it is added to diborane, trialkyl borane is formed, and after that take that alkyl borane, oxidize it. How do we oxidize it? Using H2O2. H2O2 acts as both oxidizing agent and reducing agent, but here it is doing the work of oxidizing agent, right? So an alcohol is formed. This is hydroboration followed by oxidation. Remember, an anti-Markovnikov product is formed. Now, so we can see an example here. Just a shortcut. You can remember like shortcut. So this is the alkene. You can clearly see this is a HBO going on, not the TV channel. Again, it is a reaction. And then anti-Markovnikov addition means the hydrogen attacks where there is less number of hydrogen. Here there is less number of hydrogen, so hydrogen attacks here. So the hydrogen attacks here, then the OH should attack here. Right. So OH attacks here. Now that is anti-Markovnikov addition. Let's see the mechanism. Okay. So here in OMDM, we saw electrons are being shuffled with Hg, and here the electrons will be shuffled with boron. How? So boron has this vacant p orbital, right? So these electrons go and sit in that p orbital, and then this hydrogen forms the bond with this positive charged carbon. So this will be the transition state. So this is a transition state. A cyclic transition state is seen. So this is pretty stable. And then hydrogen sits here. This bond is broken and this bond is broken. And new bonds are formed here. So this will be the first step. Means a BH2 compound is formed. Now again, the same step occurs two times. Where now this hydrogen would replace another alkene. Like the same alkene, it is there in the container, right? So it will react with another molecule, and again another hydrogen will react with another molecule. So that's why it again reacts with two molecules of this alkene, and this is formed. Instead of BH3, all the hydrogens are replaced with this alkane chain, this alkyl chain. Okay, so we call it trialkyl borane. Now the second step is, so this is called hydroboration. Means you get the point, the replacement of hydrogen. Now the next step is oxidation. Means this R bonds which are there, these needs to be oxidized. What is oxidized? Addition of oxygen. Means the H2O we are using, the H2O2 we are using here, one hydrogen comes out as H plus, and then you are going to get a negative charge like this. Okay, now what would happen next? What would happen next is this will go and attack the empty p orbital of the boron again. Okay, we are going to utilize this empty p orbital so well in boron, and then this empty orbital goes and attacks it, a negative charge develops on boron. Okay, and then the bonds anyhow are satisfied. This H2O comes out, right? Okay, ROH comes out like this. The OH comes out like OH minus, O plus, and then this alkyl group immediately donates its electrons because O plus is highly unstable, and thus this R will again meet with OH minus, and then ROH is formed. Okay, so, or you can remember like this also, 3 ROH is formed, or another suitable example will be this OH comes out, this R comes out and again attacks this O like this, and OR is formed. Similarly, all the other alkyl groups are replaced with OR. Okay, so when all the alkyl groups are represented with OR means addition of oxygen. Addition of oxygen is oxidation, right? So oxygen is fit into in the middle, right? And then with H2O, what would happen? You are going to extract this R, and then the OH goes in, I mean the H plus goes and attacks here, and OH attacks the R. Okay, then OH is formed here, and then ROH is formed separately because there are three alkyl groups here. Then three ROH is formed, and now you can clearly see, according to the mechanism, the OH group will attack here. OH is group will attack where there is more number of hydrogen. Means the hydrogen is going to go and attack where there is less number of hydrogen. When the hydrogen is going and attacking the place where there is less number of hydrogen, it is anti-markonikoff addition. So an 100% anti-markonikoff product is formed, and here no rearrangement takes place. So this is HBO, hydroboration followed by oxidation. Right? Pretty simple reaction. And in the next video, let us see ozonolysis. Thank you.